First problem asks us to draw a smooth curve and several tangent lines. Okay, well, most of you drew curves like simple parabolas and stuff, and that's fine. I chose to draw a little more imaginative curve here. It doesn't have to represent a function. It never said the curve has to represent a function. It just has to be smooth, which means it has no corners, basically. There's a deeper, more sophisticated mathematical definition of smooth, but we'll probably see that a little later in the course. Okay, so intuitively, smooth is just something you can draw smoothly. I chose 4 points here, and I put 4 tangent lines there. At each point, I just ask what line will just touch the curve at that point. Here, 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 and here. And I drew short tangent lines, and that's a fairly intuitive concept, and I don't think anybody has any trouble with it. Okay, the second question builds on this. You're asked to draw another smooth curve. Here it is. Get a little curly at the end. I'm way too imaginative here. And a point on the curve. Now the point is here. It's a little hard to see because it's a bit obscured, but we draw a secant line from the point. Okay, a secant line from the point. A secant line means just a line from one point to another along the curve. So right here's a perfectly good secant line. Of course, then we're asked to draw a secant line that's shorter, and the secant line still has to include this point. Well, I could draw one on this side. I've drawn several in red here, but I chose to draw another one here, and another one here, and another one here, and another one here. It should be pretty obvious that the slopes of those secant lines are approaching the slope of the tangent line. And if we draw really, really short secant lines, the limiting slope is going to be that of the tangent line. And again, we can also draw secant lines on the other side. I've drawn a few of them. They might look a little blurry here because they're kind of close together. But we get the idea, and your text will have much prettier pictures. I don't know if anything could be as pretty as that, but they'll have good diagrams, and they'll also demonstrate this, and their chalk isn't as wide as mine, so it's going to be a little easier to see exactly what they're talking about. But I think from this series of secant lines, you can imagine we continue this. We approach the slope of the tangent line. Okay, so this is just the idea that we can draw tangent lines, and we can get the slope of any tangent line by taking the slopes of a series of secant lines as they approach the slope of the tangent line. Could have done something very similar up here. Here's a secant line, including this point. Here's a shorter secant line, including this point. And here's an even shorter one. And as we bring the point closer and closer, the second point of our secant line closer and closer to our original point, the slope is going to approach that of the tangent line.